Lab 4, DC and RC circuits. The purpose of this lab was to explore the behavior of circuits containing resistors, capacitors, and batteries. We measured the current and the potential difference in RC and DC circuits. We observed charge and energy conservation in a series circuit, and we also observed the time dependence of a discharging capacitor. And we found the experimental time constant to be 5.963 seconds and the percent error to be 0.62%. Some fundamental principles in this lab were current conservation, specifically looking at charge conservation in applying the node rule, which is shown right here. And then we also looked at the idea of being in steady state, meaning the current is constant in time. We also looked at Ohm's law and energy conservation, specifically looking at the loop rule using this equation. So we looked at a series circuit, and the potential difference was 3 volts. The total resistance was 147 ohms, and so we found that the predicted value of the current was approximately equal to the actual one shown on the ammeter. Then the ammeter was inserted backwards, and it read negative 0.02 amps, and this is because the current is now flowing in the opposite direction. And then we replaced one ammeter with a voltmeter. The voltmeter read 3 volts, and the ammeter read 0 amps, because no current is flowing through the wire due to the open circuit. Then we applied the loop rule, and we measured the potential difference on each part of the circuit path. We summed all these values up and found that it was equal to 0, and this makes sense for a closed loop due to the loop rule. And then we graphed the potential difference versus the position around the circuit. And then we found the actual resistance values using Ohm's law. For the 47 ohm resistor, it was 47.95 ohms. For the 100 ohm resistor, it was 102.05 ohms. And these values are very close to the values that we used in the experiment. And then for the wire and the ammeter, the resistance was 0. And so then the voltmeter was connected across the 100 ohm resistor, and the current read 0.02 amps. And then the voltmeter was replaced with an ammeter in parallel with the resistor. And so we found that the current followed the path without the resistor, which was the path of least resistance. And using Ohm's law, now we have a smaller resistance and the same potential difference, so the current was 0.06 amps. Then we looked at an RC circuit, and first the battery was connected to the 10 ohm bulb and a capacitor, and so the capacitor was charging, and then the battery was disconnected, so the capacitor was discharging, and then we repeated the process for the 20 ohm bulb. We found that the current, in each of these steps, the current slowed down and then eventually stopped, which was indicated by the movement of the electrons. And also the light is initially bright, gradually dims, and eventually goes out. And then the time to charge and discharge the capacitor were given right here for the 10 ohm bulb and the 20 ohm bulb. And these values make sense because the resistance has been doubled. So then for the RC circuit, we had a circuit containing a battery, a capacitor, and a light bulb. And then while the capacitor was discharging, we measured the voltage across the capacitor for 20 seconds. And we used these equations. This was application of the loop rule, and then we did some manipulation to it. And then we graphed this, which is shown right here, for 20 seconds, and then the slope was 0.1677, and this value was approximately equal to -1 over our time constant, and so the actual time constant was 6 seconds, but the one that we got was 5.963 seconds, and so the percent error was 0.62%, which shows that our data is fairly accurate. And so finally, if you'd use an actual ammeter instead of an ideal simulated ammeter, an actual ammeter would have more resistance than an ideal ammeter, and this means that the ammeter would show a lower reading than the ideal ammeter. And if you used a real battery to charge a real capacitor with no resistor in the circuit, then the charging of the capacitor would not occur instantly because there would be internal resistance in the real battery, capacitor, and the wires. So this would result in a non-zero resistance in the circuit, increasing the time to charge the capacitor. So in conclusion, we observed the behavior and properties of circuits containing resistors, capacitors, and batteries. We learned how to create a circuit using ammeters and voltmeters, and we applied the node rule, the loop rule, and Ohm's law, and we found our experimental time constant to be 5.963 seconds with a percent error of 62%. Thank you for listening, and I hope you enjoyed this video.